Okay, this is vertical circular motion worksheet number 9. We got a teardrop shaped loop and a train on it, and it says that the centripetal acceleration with the speed of 13 meters per second up at the top, you got 2 G's of acceleration. That's the critical information about this problem. And what's the radius? What is the radius? Okay, so let me redraw this. We have your basic teardrop shaped roller coaster loop. This is kind of exaggerated, but what you'll notice here, if you notice the big picture, is that the radius down at the bottom is huge. Look at that big radius. Whereas up at the top, it's a small radius. In fact, this is what we're looking for. What is that radius? Just let me tell you, the reason why the radius is small at the top and big at the bottom is because with a small radius, you don't have to be going very fast to go around it without falling out of the train. And down here, you're going to be going really fast because gravity is speeding you up. And if you go really fast at the bottom of a loop that's very tightly curved, you're going to black out because the G-force is going to be really big. And in fact, what we have in this problem, we're told that A sub c is equal to 2 G's. So 2G, G is 9.8, surface of the Earth, the acceleration of gravity. And the picture here is you need enough force to execute this loop. You always have, I'm just drawing a line next to this here, there's a train here, okay? You always have mg. Mg provides some, if not all, of the centripetal force. You want to design this so you need more than mg, and that other part is called the support force. Additionally, you need support force plus the gravitational force to execute the loop. That means that the support force, which is the track pushing on the car, and you, is non-zero. It's pushing down on you. You feel it. You're upside down, and you feel a seat force on your rear. That's what you feel. All right. And you want to feel that, otherwise you may be falling out of the loop, and that's not good. So AC is equal to 2 G's. Well, this turns out to be really easy. A sub c is equal to v squared over r, right? And so what do we get from that? We can solve for the radius. We can solve for the radius. Radius is equal to v squared over a sub c. That, according to this problem, is, well, here, let me just, well, yeah, I'll just write the numbers. It was 13.1 squared. A sub c is, this is equal to 2 G's, which is 19.6, and that gives us 8.6 meters. There's the answer. That's how you get that. All right, that was A, and now we have B. B, the total mass. Total mass M. What is the support force, is what they're asking for. The force the rail exerts on it at the top. That's the support force, and that is going to also be your sensation of weight. Well, since A sub c is equal to 2G, which consists of, well, let me do this. I think this will be more clear. We have the total force, the net force, Fc, consists of mg plus support force. And that's equal to, produces 2 G's, so that's like 2 times your weight, 2 mg, right? So the centripetal force total is 2 mg. Well, there's 1 mg, so what's this? The support force is also mg. Now, m is general, the mass that we're talking about. So that's what the support force is mg. 1 mg provided by weight, 1 mg provided by support force. So if the total mass is m, then the support force for this problem is equal to big M times g, which is also, you could say, is equal to 9.8 m. There it is. That is your answer.